Alright folks, in this video we're going to learn more about the law of cosines. The last video we talked about the law of sines, and we had some specific information we were looking for in order to use the law of sines. Similarly, in law of cosines, there's only certain pieces of information that we need in order to use law of cosines. And just like law of sines, right angles are not a part of it. We don't necessarily need right angles. The first situation we're allowed to use law of cosines is if we have been given the length of all three sides of a triangle. We don't know anything about any of my three angles. If I know all three lengths, then I can use the law of cosines to find any angle measure. The second situation is if I only know two of my side lengths and the included angle measure. It only works, for our purposes at least, if we know the included angle measure. And we are looking for the third side length, the length of the side opposite our included angle. So, those are the two major focuses we're going to talk about. Unfortunately, the law of cosines is much more complicated. As you can see, there's really 6 different ways we can look at this. If I am solving for a side length, I have a very complex formula that we need to know. Luckily, I'm not completely a jerk, and I'm not going to make you memorize it. So when you do take your quiz for this part, the end of this week, you guys will be allowed to use your notes. So make sure you mark on your notes where these are located or when you can use these. If I am solving for the side length A, I will use this function, that a squared equals b squared plus c squared minus 2 times b times c times the cosine of my angle. The thing that I want you to recognize, and when I'm using this, if I'm solving for side A, the cosine, the trig function I'll use, is the trig function of the same pair. And it's just different every time I'm using a different side length. Sometimes teachers just make you use or learn this sort of formula for the side length. I'm going to give it to you as the angle measure as well. So I'm going to tell you that if you're solving for a side length, you're using one of these 3 formulas. If you're solving for an angle measure, you're using one of these 3 formulas. In addition, if you're solving for an angle measure, at the end, you're going to have to use your inverse trig function. Example, if I want to solve this and I know A, B, C, I can solve this by saying that A is the inverse cosine of my negative A squared plus B squared plus C squared over 2 times B and C. But enough of that. Let's go to look at a few examples on the back page. Go ahead and take your calculator out right now as well. You're going to definitely need that, and make sure it is in degree mode. Alright, so for this first example, they want us to solve for little g. Little g means it's the side length opposite big G, our angle G. That's this side length here. It's segment FH. So we go back to and think about our function. They're solving for sides. So I'm going to use this law of cosines formula. And I can just leave that up here. We can look at it. The one I'm solving for should be on the left of my equal sign. That means I'm going to use g squared equals. I'm going to square and add, so find the sum of the squares of my other 2 sides. In this case, my other 2 sides are f here and h here. So it's the g squared is going to equal f squared plus h squared minus 2 times these without squaring them, times f times h, and the cosine of my included angle. This 87-degree angle is formed by or included between the 2 side lengths I know. That's the angle measure I'm taking the cosine of. So, or in other words, if I'm using just my symbols, that's angle G. Solving for side G, use angle G. With that set up, I can go ahead and start plugging everything in. I know I'm going to have f squared. Every time I substitute, I will do that in parentheses. F is 15 squared. H squared, substitute h with 16 in parentheses and square it. minus 2, substitute for f, again, it's 15, times h, which is 16, times the cosine of my angle, which is 87 degrees. Now, I could put g squared here, but g squared isn't what I'm solving for. I'm solving for g. In which case, I'm taking the square root of both sides. So all of this has to be under a square root. Then I can get rid of the exponent, and I have g. Taking my calculator out, I can do this all in one step, or I can do it in as many steps as it takes. If I am doing this in one step, parentheses are incredibly important. So, I'm going to show you doing this in 3 steps. I think that tends to be a little less confusing. I'm going to start by simplifying my squares. 15 squared plus 16 squared gives me 481. Okay. Bring down my minus. Now I'm going to simplify the 2 times 15 times 16. All of this at the end of the day is still going to be under my square root. So step 1, simplify my squares. Step 2, simplify my other multiplication. 2 times 15 times 16 is going to give me 480. And I still have cosine of 87. This is a lot less confusing to put into my calculator. That's why I'd have you simplify that first. Now in my calculator, I can type in my square root button. It should automatically open up parentheses. Or if you have the newer format for the TI calculators, it's going to just keep extending your radical, your square root bar as you go along. And I can type in 481 minus 480 times the cosine of 87. So cosine 87. If it opens up parentheses for you here for cosine, you have to close those. Then close the parentheses for your square root here. Hit enter. I will round it to the nearest tenth because it is a side length. 21.4. Go ahead and try our next example, please. Hit pause. When you're done, unpause to check your work. No cheating. Hit pause and try it. And we should get that side length P is equal to 47.6. Here's what we should have used. Substitute in what we know. If we simplified everything, this here would have given us 221 minus this here would have given us 220 times the cosine of 38, and of course all of that would have been under the square root symbol. Okay. The last full example is the second situation we can use law of cosines. In this case, it's when I have 3 side lengths. I don't know any angle measure. I'm looking to solve for all 3 angle measures. The good news is, I really only need to solve for 2 of them, because the third I can use triangle sum theorem. So if I'm going just to go in order here, I know I'm looking for angle measures. Going back to the first page, if I'm solving for an angle measure, I'm using one of these 3 formulas. So in this particular example, I know I'm solving for angle N. I'm going to say that the cosine of that angle, N, is equal to the side opposite is the side that's always negative. I'm always going to have my 3 sides, which is n squared, I squared, and u squared in my numerator. 2 of them are positive, 1's negative. The negative one will always match the side opposite, the angle that's your reference angle. In this case, angle N is my reference angle, so it's minus n squared plus I squared and plus U squared. The denominator is always 2 times my positive side lengths, I and U. Now that I have all of that written in, I can go ahead and substitute. I still don't know what n is, but I do know that I have all of my side lengths. You see how I'm doing this is substituting with parentheses first, so I'm not even putting anything in here but the parentheses. Now I can go in and fill. N, lowercase n, is the side opposite my angle N. That's a 55. So that goes in here. I squared means the side opposite angle I, which in this case is 30, goes here. And U squared, that's this side length here, is 37, goes here. I and U go in my denominator, so that's 30 and 37. In this situation, what I would recommend doing is simplify your numerator, then simplify your denominator in your calculator. So I'll clear all of this out. Type this in exactly as you see it with the parentheses. Negative parentheses 55. Oop, didn't get my parentheses. Close the parentheses squared. Plus parentheses 30. Close the parentheses squared. Plus parentheses 37. Close the parentheses squared. Hit enter. That's going to give me a numerator of negative 756. So I can go in here and I can state that I have the cosine of angle N equals, and we had negative 756 in my numerator, over, do the same thing with your denominator, 2 times 30 times 37 is 2,220. This should look familiar. This is an inverse cosine function now. The last step would be to take the inverse cosine of that fraction. So second cosine negative 756 divided by 2,220. Close my parentheses. I get an angle measure of 109.9, which to the nearest degree is 110 degrees. That's my first angle measure. I don't know enough to do triangle sum theorem yet, though, so I do need to do this all over again. But I'm going to do it with angle I as my reference angle. So what I'll do is just set up this equation, and then we'll talk about our answer. So I use cosine of angle I is equal to, in this case, my n squared is positive, 55 squared. My I squared, because I is my reference angle, is negative. So minus my I, which is 30 squared, and my U squared is positive because I is my reference angle, and it's 37 squared. And it's divided by 2 times not I and U anymore. I is my reference angle, so it's not included down here. It's N 55 and U 37. Go through the same process to get your calculator set up. Use your inverse cosine function, and we should find that we get an angle measure of 51 degrees. Once we get that second angle measure, we can finally find our third angle using the triangle sum theorem. So 180 minus the 110 minus the 51 should give us an angle measure of 19 degrees for angle U. This last example here is set up in a very similar way. I want you to go ahead and try it on your own. After you press pause, unpause to check all of your answers. And law of cosines should have got us 38 degrees using this equation for angle H, 92 degrees using this equation for angle D, and triangle sum gets us 50 degrees for angle J.